right. Hello, everyone. Now it's 9.1 scale factors. Okay, scale factor. So in this chapter, now take a look at the polygon. All right. So it starts with an explanation of what polygon is all about. So that means we're not dealing with equations anymore. Now we're dealing with geometrical shapes. Okay, so as soon as we deal with shapes, then we fall into the area of geometry. This one has nothing to do with proving in geometry, but pretty much it is calculation again. But again and again, it's not equation anymore. So now take a look at all the names of the polygon. You should be perfectly fine with all these things. It's only counting is all in Greek word. Now, Greek word, again, we're saying poly means many. Gon, sides. So, pentagon could be just called 5 gon, 6 gon. But they use the Greek words, okay? Now, triangle, this is, in secondary school, we often just deal with the triangles. So then there's equilateral triangle, there's isosceles triangle, and there's a Sacline triangle, okay? So now understand their definition of the three triangles. Quadrilateral, now you please take a look at all the quadrilaterals it's all about. You definitely have studied this in elementary school. Similar figures, this one is new in this section. So what is a similar figure? If they're similar, that means their angles are absolutely the same. Corresponding angles are absolutely the same. Now, also the sides are proportional. The sides are proportional. If they're exactly the same, then they are the same triangle. That's called a congruent triangle, right? So the angles are the same. Angles are all the same. And then the side, the three here. And the side, if this is triangle ABC and triangle DFE. If AB equals to DC, and the other two, same thing, AC equals to DE, and BC equals to FE. Then these two triangles are absolutely the same. That's called congruent. So they are congruent. They're congruent triangles. But they're not the same. One is only, this one is this small. Then the other one is much, much larger. However, still, the corresponding angles are the same. And the length now is in proportion, means this one versus this one equals to this one versus this one equals to this one versus that one. Versus means, so if AB compared with DC, that absolutely equals to AC compared with DE. The third sides are exactly the same thing. Now BC will be over FE, that's also equal. In this case, we say this triangle and this triangle are similar. They're not congruent, but they are similar. And congruent, we use triangle A, B, C. It is congruent like that, triangle DEF. However, when it's only similar, we just use this symbol. So we do not have the equal sign. So triangle A, B, C is similar to, see, the way I write this one is reverse of your textbook. I think either way is fine. So that called similar. Okay? Now, the next one is now what is a scale factor? The scale factor is basically you compare with one to another. So this is called an image and object. So in this case, you will know maps. When you draw a map, that is similar to the real landscape, right? But when you draw a map, you cannot, like, you know, from Lower Bing to UBC, for example, if that's 3 kilometers, or how many, I don't know, 4 kilometers, you cannot on a piece of paper draw a 4-kilometer long line, right? So you have to shrink it. So when you shrink it, that becomes an image. So the scale factor is that if the image is smaller than the real object, then that is a reduction. But if you draw a small, very tiny bug that you can only see under a microscope, and then you have to draw a much, much larger bug that is not the real bug. So then your image is larger than the object, then that is called the enlargement. Okay? So can we calculate the scale factor? Yes, we can. Or can we measure the scale factor? Yes, we can. All right, so we're basically, I'm just using the method 2. This is much more straightforward. So if you have equilateral, then AB versus BC, AB versus A dash, B dash, BC versus B dash, C dash over here, then that is just your scale factor, okay? So if it's a drawing, you just have to measure it and then figure that out. Now, if this here, so there's 2 equilaterals, 4 sides of a polygon. So in this case, this angle equals this angle and this angle equals. And in that case, this angle has to equal to this angle. So this angle is 80 degrees, right? Now this angle and this angle have to equal, so then that is 105 degrees. Or you use this one, this one, this one, add together, 360, subtract that, give you that. This one, this one, this one, this one, this one, 360 subtract this 3, give you 80. So then therefore, all the corresponding angles, they are the same, therefore they are a similar triangle, right? They're a similar triangle. Sorry, I should be underlining it, but I crossed a line. All right, so the scale factor, you just have to pick up EF and then AD, and then the scale factor is smaller than 1 because this is small, that is large. So from this one to that one is enlargement. Am I talking about correct? Yeah, so this is EF, and that is that. So this image is object. So from the object to the image, this is reduction. Therefore, it's smaller than 1. And then this one, take a look at by yourself. That's its method 1. So you don't have to do method 1. And then you can do the question in the exercise. It should not be difficult whatsoever.